Okay, lesson 11.3 on parabolas. Let's do this. Okay, so talking about the conic section of a parabola. So a few things I want to remind you. So remember, we're talking about conic sections. We're talking about if I take a double-sided cone like this, right? Double right circular cone, whatever. The conic section is what we're talking about. So it's when I take a plane like this and sort of slice into it, and I get this parabolic shape here. So this here, I'm going to kind of try to shade it in here. This cross section or whatever is a parabola. Okay. Okay. Hopefully that's evident. I don't know. There you go. So that's my parabola, right? And that's where it's coming from. Now, what I wanted you to think about is we've talked about parabolas as functions, right? Y equals ax squared plus bx plus c. Good old standard form of a parabola, right? We've talked about vertex form, a times x minus h squared plus k. We've talked about factored form, a times x minus root 1, x minus root 2, right? We've talked all about that. But that's talking about the function, the parent function that's quadratic, x squared, right? What we're talking about more now is the actual geometry, the shape of a parabola, rather than, just of it as a function. So there's a little bit more to it now. Keep in mind, it's the same thing. I mean, you can define this stuff as a function anyway. It's the same thing. It's just we're interpreting it in a little bit of a different context because we're looking at the geometry of it. So what is a parabola? Well, a parabola is it's constructed from two things. It's constructed from this focal point, the focus, right here, and then it's constructed by the line like so. Now you can draw this focus and this line anywhere you like. You can put a point here, draw a line, it'll make a parabola. You can put a point here, draw a line, it'll make a parabola, right? You put a point here, draw a line, it'll make a parabola. So to construct a parabola, you need a point and a line. And so what are these points called, right? What are these features called? So the vocabulary first. A parabola is a set of all points in the plane that are equidistant from a fixed line we call the directrix. So that's what that line is. And a fixed point not on the line, which we call the focus. So this is the geometrical definition of a parabola. Okay. And so what does this mean, right? What does it mean? Equidistant, right? So if you look at this is my directrix here, right? Directrix. If you look at this parabola that we have, what it means is every point, so let's say I draw a point here, right? This point is equidistant between the focus and the directrix. So if I draw a straight line going right to the focus, and then I draw a straight line dropping just kind of perpendicular down to the directrix, these two lines are the same length. And so every point on the parabola follows this feature, right? If I pick a point here, this distance and this distance are the same. And since I created this parabola in GeoGebra, so I'm pretty sure, I mean, these, you could probably take a ruler and draw it to the screen right now and see that they're the same length. I mean, like maybe there's human imperfection of my drawings, right, of these lines, but really, take a ruler to the screen. You should find that these are pretty much the same length. It should be exactly the same length. And so that's what a parabola really is it's all these points that are just as far away from that line as they are the focus. Okay. Now, the vertex is probably the easiest one to see here, right? Because the vertex is, if I draw a line straight from the focus to the directrix, the vertex is just halfway in between, okay? Now, this distance from the vertex to the focus is called the focal length, denoted by P. So you might go back up here and fill that in the blank. The length from the focus to the vertex of the parabola is called the focal length, denoted by the variable P. Okay, why is it P? Why is it not F? I don't know. Why is it not L? I'm not sure. It's probably comes from somewhere. Okay, and you know, if you see this, right, if the distance between the vertex and the focus is p, and every point on the parabola is just as far from the focus as it is the directrix, then the distance from the vertex to the directrix should also be p, right? Those two lengths should be the same. Okay, and that's the focal length. The vertex, as we already know, is the point h comma k. We've seen that before because we've worked with vertex form before, right? So that's not new. You might be saying, well, I thought h comma k for conics was the center. And I say, yeah, where's the center of a parabola? It's at the vertex, right? The center of a circle isn't at its vertex, but the parabola it is. So, yeah. Okay, so more vocabulary. So some chord of the parabola. I'm going to fill in these blanks in a second. But if I draw a chord from here to here, okay, that length here, from here to here, that length is parallel to the directrix and goes through the focus. This is called the latus rectum. That is what is the sort of Latin name for it. So the latus rectum of the parabola, or, you know, is a chord on the parabola parallel to the directrix and going through the focus. Okay. The axis of symmetry, well, we know what that is, right? It's a point where it's the line where it's symmetrical. That's the axis of symmetry. Notice those two lines, the directrix and the axis of symmetry, are perpendicular. Perpendicular. Cool. And by the way, if you wanted to expand your vocabulary, if a new word for perpendicular, orthogonal. Yes. Orthogonal is a sort of synonym for perpendicular. It means kind of the same thing. I don't know if you want to use that word. It's just interesting. Okay, and then finally, the latus rectum is also called the focal width. So that's the same. So latus rectum, focal width, same thing. So the focal width is, well, actually the focal width is 4 times the focal length. So from here, this distance to here, that's 2p, because, you know, this distance from here to here is also 2p. So 2p plus 2p is 4p. And that just is kind of how that works out. It's just the geometry of a parabola. And there you go. Okay, so standard form equation of a parabola. How do I know when it opens vertically versus horizontally? Vertically is x squared. Horizontally is y squared. I know it kind of seems a little backwards because you're saying, well, well, we know y equals x squared is your parent function. That's your typical parabola, right? If you say x equals y squared, well, whoa, what is that, right? That's not a function because it fails the vertical line test. So x squared vertically, y squared horizontally. Notice the focal width is 4p, and you're multiplying that times the other variable. So it's just another way to write it, okay? This is still basically vertex form because it tells us where the vertex is, but it's a little different because we're talking about the shape of it rather than, you know, the function. It's not solved for a particular variable. It's not solved for x, and it's not solved for y. So it's not a function, right? Anyway. So it can open vertically, right? It might look like this. If it opens down, it might look like this. And notice that focus is sort of scooped inside, right? And the directrix is always behind the parabola, if that makes sense. That's the directrix. If it opens horizontally, it could open to the right like this with the directrix out here. Or it could open to the left like this with the directrix like this. Yeah? Those are my parabolas. What are these weird symbol-looking things, right? And then down here, it's going to open up or right if p is positive. It's going to open downwards or left if p is negative. And that's just kind of facts to know. All right. So here we go. Let's graph a parabola. And all I got on this video was one example. So that's all we got to do. So let's graph the circle. Oh, graph the circle. You mean the parabola. That's what you meant, right, Mr. Spake? I said, yeah. Okay, so let's graph this parabola. So it says y squared. So this opens horizontally. So it's going to open left and right. I don't know whether it's right or left. I kind of have to figure out the x's and all that business, right? Now, if I look at my equation here, right, laser, this fella, right, y minus k squared is isolated. So the y's are on the left side and the x's are on the right side. So here's what I need to do. I need to isolate y. So I say y squared minus 10y plus blank, because you know what I'm doing. I'm completing the square, equals, I'm going to move the 12x over. That's 12x plus 13. Oh, sorry, minus 13. Because I'm subtracting it to the other side, plus blank. Now what goes in that blank, right? I take negative 10, I divide it by 2, I square it, that gives me 25. So that's 25, and that's 25. So what I get here is I can factor this, y minus 5 squared equals 12x, and then negative 13 plus 25 is 12. And you might say, okay, I'm good, right? Well, you almost. Real quick here, notice that 4p is factored out from x minus h. This just says x minus h. It doesn't say 2x minus h. It doesn't say 12x minus h. It says something times x minus h. So whatever that coefficient on x is, you need to factor that. So I should say this is y minus 5 squared. I'm going to factor out 12. So do 12 times x plus 1, because I'm factoring out that 12. Okay. Notice that the vertex, I forgot to type that in the notes here. The vertex evidently is at negative 1, comma 5. So how did I get that, right? Well, it's x minus h and y minus k. That's how. So that's where my vertex is, because it's h comma k. So negative 1 comma 5 is up here. What's my focal length? Well, 12 is the focal width, right? So 4p equals 12 tells me that p equals 3. Just divide both sides by 4. Okay. Now, I might ask myself, okay, is it opening right or is it opening left? Opens which direction? Well, p is positive, so it's opening right since p is positive. So I'm going to go 3 to the right to find the focus. So let's see, this is the vertex. So go 1, 2, 3 to the right. That is the focus, and that is 2 comma 5. Then I'm going to go back 3 from the vertex. 1, 2, 3 here. And that is the directrix. Okay? My directrix D. Cool. And that is at x equals negative 4. Okay, because I subtracted 3 from negative 1. And you can see that my axis of symmetry, right, it's perpendicular going through the vertex. That's at y equals 5. Now, I'm almost there. You might say, oh, well, can't I just make the curve and be done? Well, no. Let's make it at least a little bit more accurate. You know, I mean, you find 4 points on a circle and an ellipse. You find the asymptotes for the hyperbola. We should find something a little bit more than just the vertex, yeah? So I'm going to find 2 points, and the 2 points I'm going to find are namely these guys. So I'm going to use the latus rectum to figure out 2 more points. Just to kind of tell me, you know, how wide is this thing really, right? Is it a skinny parabola like this? Is it fat like that, right? What is it? How wide is it? Well, P equals 3, so 2P equals 6. So that means you're going to go up 6, down 6. So up 6 and down 6 from focus. That will help you find 2 more points. So the focus up 6 should be about here, because that's 11, right? That's 11. And then down 6 should be down here at -1. Okay. I'm going to lasso this. Let's take this fella. Ooh. Let's take you. Let's move you. I don't know. Here. That's fine. Okay. And now just try to do your best to draw a parabola. So I'm just going to kind of lightly do this. Boop. I'm going to kind of curve it back around and keep that nice big point. And curve this way through the point, like so. Nice. Okay. It's not perfect, but it's serviceable. It's pretty good. And that's my parabola. Yippee! Okay. So that's it. I mean, this should be familiar. The only really new thing is this whole, you know, lattice rectum and then the directrix. That's a little bit new. Right, but aside from that, it's good old parabola, good old quadratic, and we're feeling good. So, hope you enjoyed the video, and I'll see you around.